So there we have two equivalent fractions. A property of fractions, if two fractions are the same, if you flip both of them, are they still the same? So the question is, since I have 2 over 7 is equal to 4 over 14, is it true that 7 over 2 is the same as 14 over 4?
Correct.
If I flip both of them, are they still the same? Or, I mean, 2 over 7 isn't equal to 7 over 2. I'm not trying to say that, but I'm wondering, this statement, we said this first statement is true. My question mark, is this one true or not? So 7 over 2 is not equal to 14 over 4? Or are they equal?
They're equal.
They are equal? So if I had the first one equal, if I flip them both, it seems to be the second one is equal. But just doing one example in math doesn't necessarily mean that they're always true. So let's try another set of fractions. Pick two other. 97 and 43? Wow. Let's do some smaller numbers so we can do the I mean, I can do the mental math with 97 and 43 and make
15 over
Let's-
20.
yeah.
15 over 20.
15 over 20. That's smaller. Would you agree that 15 over 20 is the same as 3 over 4? Yes or no? Yes. What did I do? This is true. What did I do to go from here to here?
Divided.
I divided by 5, and I divided by 5. Yes, that's true. So now we did another two random numbers. If I flip this one, 20 over 15, and I flip this one, 4 over 3, is it still true?
Yes.
Yes, it is.
Just flip them.
I just flipped them.
We still don't know if that works for 93 over 47.
We don't. Now, we've done two examples. I'm going to tell you that this is always true for fractions. If you've got two equivalent fractions that are equal, and you flip them, they'll still be equal. They will be different numbers, because 20 over 15 isn't equal to 15 over 20, but you will still have an equation that is true. And this comes to be important because we can use it for a shortcut if we get questions like this one. 5 over x is equal to 1 over 3. We don't have to worry when we're doing the pattern method, but when we're doing the algebraic method, we do have to worry about this because now the x that we're solving for is on the bottom of our fraction. And there are some algebraic steps that can get that x out of the bottom of the fraction. We're not going to worry about those because it's easier with the pattern that we just saw to say, well, if I have two fractions that are equal, I know that if I flip them both, so if I flip the first one, instead of 5 over x, I get x over 5, it's going to be equal, instead of 1 over 3, 3 over 1. Now the x is on the top, and we can use the same algebraic method that we did before. What you do to one side of the equation, you do to the other. Right now, our x is being divided by 5. Opposite of dividing by 5? Multiply by 5. So if we multiply the other side by 5, we're going to get 3 divided by 1 times by 5 is 15. So if we're going to use the algebra method and we have the x on the bottom of the fraction, we're going to do one extra step right here. And all we did, whoa, I'm spelling flip wrong. Is we flipped both fractions. So if our x is on the bottom and we want to use an algebra method, we're going to have to flip both fractions. And then the ratios will still stay the same, and then we can solve. And when you multiply by 5 on both sides, these 5s cancel out, leaving us just with x and then we can find it. The pattern method, if you can do the pattern method, you don't need to flip. So here we had 5 over x, 1 over 3. We want to go from here to here to find out what x is. So if I was up here going from 1 to 5, what would I have to do? Multiply by 5. So down here, if I multiply by 5, 3 times 5 is 15. And so we get x is equal to 15. So it works for the pattern one as well. Here's one for you to try with both the algebra way and the pattern way. So we'll start with the algebraic method. And then we'll do the pattern method after that. Now with the algebraic method, our x right now is on the bottom of that fraction. So what we notice with our fractions, that if two fractions are equivalent, then you can flip both of those fractions, and that equation will still be equivalent. So now, after I flip it, I have x divided by 18. And what I do to one side of the equation, I do to the other side of the equation. So the opposite of dividing by 18 times by 18. And you'd go to your calculator and you could type in 7 divided by 2 times by 18, and you will get 63. That's everybody cheering when they got the right answer. Awesome. All right. So with the pattern method, we start with 18 over x is equal to 2 over 7. We want to find out what x is. So if I draw an arrow saying, what would I have to do to that 7 to get to the x? Draw the arrow in the same direction up here. Well, how do I get from 2 to 9? I have to multiply by 9. So then if I multiply by 9 down here, 7 times 9, and I get x is equal to 63. Woohoo!